My turn?
Right now, we're on the island.
Yeah, I'm gonna start the my turn now. It's best at the stairs. From there, it's downhill.
There you go. Okay, so for the plan for our arms, the main problem was there wasn't a plan. We just kind of started building. All we wanted to use the pulley because then we didn't have to use as big of a counterweight, so that works really well. That was pretty much it. We just thought of ideas as we go.
We started our basic idea was to replicate the arm. So we would have a tower holding it together. This, we would have a motor here and a motor here. When all the joints were in place, we made the final program and tested the arm. Noah was the programmer. I had the hardware. The arm didn't work at first couple of tries, so we started debugging the program and making modifications of the arm. Since we have no sensors, we had to time everything, like Ken did. We incorporated pulleys, as you can see there, to raise the top, to lift the weights at the top.
And rolls. Okay, so we were successful in making the robotic arm that can take up the top. The problem was making the upper arm able to lift the weight of the rest of the arm, so we had to use a counterweight for that. And then the main obstacle was the hand. We had to try a couple different designs before we finally found one that would actually work. And then the problem was we had to make the timing perfect, and as you can see, it's still not perfect. We have to make sure it's in the exact right spot before it'll work.
And having a pulley, every time we put it back into its normal position, we don't know how much it's going to go down or up. It's trial and error, but for the mind, so you can find the perfect position.
So if we were to do it next time, we'd probably use a motor to power the thumb, and our hand, we kind of got lazy and didn't want to keep cutting metal, so we have some excess metal sticking out of the side of our hand that isn't interfering with anything. It just looks kind of weird. So if we were to make improvements, we'd use a motor on the thumb and we'd cut off some of that excess metal. We'd also probably make the fingers longer, so it wouldn't have to be in such a perfect spot to pick up the cup.
The main lesson we learned is to plan before we start. And another big problem was group communication. Because me and Noah didn't get along very well together. So an improvement could be communicating better, listening to other people's ideas, and get more organized.
Alright, so the Lion Robot is me and Ryan working together. In the project, we need to build a robot to drive search into a room, telepon beacon. We worked on the project, but we really didn't have any kind of planning. It was mostly programming, so we kind of wrote whatever we thought would work and tested it out.
And attempts to debug whatever happens. What's usually involved?
Just getting help from our kids.
So the robot is probably good, but we did it, and we used, I guess, a linear logic, and we used a C/C++ program. Our program has features problems such as getting stuck in the virtual boosting at the beginning, but for now it's kind of bouncing around it. It also has the ability to find the way out because I think right now it's just vector and randomly until it's just done to find the way out. And we try to solve these using the manipulating code that Ryan gave us.
If you were to try to plug it in, you would probably improve project by understanding the teams parts more, so we can actually know what these parts are doing and how we can manipulate it to make it more effective and accurate, and hopefully less buggy. Also, we would try to plan so we won't have extraneous code. There's a lot of time where we
even if we attempt to fix an issue with the robot, there's always going to be another one that pops up because it seems as if every time we try to type something in, then 5 more errors would show up in processing. We really shouldn't assume that something is going to work because even when the processor said that the logic was correct, in practice, this thing is still bouncing around.
Alright, Mark and I did the my son's robot. So our plan and our process, first we tried to build the robot without actually planning anything first.
First of all, the manual. We had the manual, so we built it exactly to specification. But that didn't really work out, and so we took it apart, and then we started with the four-wheel design. So that's in the next slide. But so yeah, our plan was to build it, program it, and then debug it.
Okay, so our main idea with this project was trial and error mainly. After we got our final design done, we programmed, and the main problem was to pass the cinder block, so we tried to get the timing correct to get back to the line after we passed it.
So the first model was the four-wheel design. The greatest challenge of it is trimming, as you all know. It takes forever to turn. So we realized this, and so Model 2 had, it had 3 wheels, the small one in the back. It solved the problem of turning, but suddenly we were having problems with following the line, going down the stairs, and traveling in a straight line. So and I was getting stressed. I was starting to sweat a little bit because we were running out of time. So we decided to go back to Model 1 and try to see if we could solve the turning problem.
Okay, so obstacles. One of our major obstacles was figuring out how to work the programming so that the robot would follow the line and pass the immovable obstacle and then get back to the line. We obviously didn't fix that correctly. Another problem was with our second model. We tried to build a spinning wheel to put on the back of the robot, and we ended up scrapping that model anyways. Let's see. The third model, our largest obstacle was getting the steering to work because it wouldn't steer. So
one wheel is not properly touching the ground because some alignment problem or something like that. So not yes. Sorry, that one. Yes. One of the wheels is not properly touching the ground because it doesn't have enough traction. So that's why steering is really hard. So me and Alex switched off with building and programming. So we learned that. We collaborated with the other groups to see what they were doing correctly and what we were not. So yeah, how to program using Mindstorms. I'd used Mindstorms before, but not for this level of detail. And that's really cool.
okay, so how would we start the project differently? First, we would think about our structure before we actually started building. Like at the beginning, we looked straight at the manual and just built from that. But then we figured out that it wouldn't work. Let's see. Second, we would draw up a design while we were thinking about it, and we would plan out the robot programming more using a flow chart.